we have is a wedge of 4M rests on a smooth horizontal table. So you're talking about your wedge here, which is always a triangle, and then it rests on your table like so. And one of its faces, which is smooth, so smooth straight away means no friction, makes an angle A with the table. So angle A, where tan A equals 3/4. So remember, 3/4 is opposite over adjacent. Do Pythagoras' theorem to get to 5, and now you know that cos A is 4/5, and sin A is 3/5. Okay, so you've used that piece of information. A particle of mass m is placed on its face. Mass m is placed on its face, and the system is released from rest. Find the acceleration of the wedge. So this question just wants the acceleration of the wedge. So the whole goal of the question is to find out what A is. Okay? We can find out what F is anyway, or we may need F to find A. We don't really know just yet. Okay, so let's draw our diagrams. We have a reaction force R. We'll have a second reaction force S supporting the wedge, and then we'll draw our two diagrams separately and our acceleration triangle, isn't that right? Two diagrams, acceleration triangle. Okay, so what we're going to do first is we'll start off with the mg, mass m. So its weight going directly downwards, and then across, and then down. Anybody tell me what angle this is here? Angle A. Okay, good. Same reason as always. When you draw it directly down, that's going to be 90 minus A, and therefore that there has to be A. Okay. Now that that's done, what we have next is we got to break it up into its components. So it's mg going directly downwards because its weight has to go directly downwards. We're going to have mg cos A and mg sin A going down and to the left. Is that right? So mg cos A being 4/5 and mg sin A being 3/5. So 4/5 mg and 3/5 mg. Okay. Leaving something out of that diagram, remember it's all about the forces. What force am I leaving out at the moment? Leaving out R. Okay. So that's all the forces. Now you can say that its acceleration down here is F, but F is not a force, okay, so I'll just leave that in green. F isn't a force, but everything else in that diagram is. Okay, next we're going to zone in on the wedge. So we'll just group that together for a second as well. Okay, so next thing we're going to do is the wedge. So here we are here. Now, so from the wedge's perspective, guys, we'll just make it a bit bigger, makes it easier to control. So, what can we say about the wedge? What forces is it experiencing? What does it experience coming in this direction here? R. Experience R. Okay. Now, we have to do something with R. Can anybody remember what do we do with R? So R, this is angle A, this is 90, therefore that's 90 minus A. All this up here is a 90-degree angle, so 90 minus A plus A is 90 degrees, so that tells us that the angle is A. Now we're going to resolve R into because the wedge's acceleration is going directly to the right, yeah? All forces for the wedge must be resolved straight up and straight across. Because the particle is going down in this direction here, all forces must be resolved either perpendicular to that or parallel to that. Okay, that's how you know which way to resolve the forces. It's all to do with the arrow it's all to do with the direction of the acceleration. So from the wedge's point of view, I have to have everything going up or to the right and left. From the particle's point of view, it's got to be going along this slant here, or up and down along this direction, okay? So that's how you know which one to do in which directions. So we have R there. So this side here, I'm about to shade in red here. Anybody? R cos A, otherwise known as, what's cos A? 4 over 5R. The next one in blue, anybody? Or sin A, otherwise known as 3 over 5R. So we've resolved R into its different parts, okay? Now, I've left out other forces at play. Can anybody tell me a force that goes directly down? Usually from the centre, but the centre is occupied at the moment. Here it is here, 4m. So what goes directly down? 4mg. Something that goes directly up. A letter of your choosing. It's a force that balances up. Usually I threw an S earlier on, so it's going to be S. Okay, so we have R, we have the weight, and we have S. That's everything, okay? So what we're going to be doing next is, I've done, with my system, I've already drawn the wedge, I've already drawn the particle, I've resolved R in the directions of the wedge's acceleration. So comes next is the acceleration triangle. Now I always go down to the acceleration, draw a line, and I imagine this in my head. Imagine putting it there. Then I go along the line of the wedge, and then I draw it going down. Now the diagram can get a bit clustered at times, so what I can just do is I just transfer it down here. But you can see basically how to draw it, and you remember that it's an angle A in here. Your acceleration is this one down here. Now that's 90 degrees. Can anybody tell me for this, you're accelerating directly to the right, which means this direction has to be what? Diagonal up and right, and this direction? Diagonal down and right. Okay, because it has to be the same as just going straight across. Okay, now that you've done that, what's this? Can anybody tell me what this value here is? Okay, it's going to be A cos capital A, but as you said already, cos A is 4 over 5, so it's 4 over 5A. And then the other one, A sin A, which is 3 over 5A. Okay, 3 over 5A. So just recheck your checklist. Wedge done, diagram particle done, or triangle done, acceleration triangle done. Now we can move on to the formula section, okay? Start off with the, put an F here. F's not a force though. Oh, sorry, A. Put an A there. Now, let's look at the wedge much closer, and let's make a formula for the wedge. So, it's always F equals ma. That goes without saying. So what forces are at play bringing it to the right? Anybody? Three over 5R. And then MA 4M. 4M is the mass, and then just acceleration of the wedge, A. So there's your first one of them done there. Okay, so I can just switch that out now. Take this one in down here, and we'll do our next formula. Okay, looking at this diagram here. So that's the wedge. The wedge is done there. Okay. So what we're going to do next is we're going to do. We have two equations. both f equals ma, but you got to choose the direction. You can see that the acceleration is going this way, so you have an equation that goes down this direction here, and you'll also have an equation that goes up and down the other way. You take your choice, usually down, because it's sliding down. Okay, so you're going to have an equation going across and an equation going down. So let's do the across one. What forces are dragging that across the plane or down the plane? Anybody tell me? 3 over 5 mg. Good man. And then 3 over 5 mg is perfect. M, it's just m, isn't it? Okay. And then what about the acceleration? Acceleration going downwards. F is perfect, and then it's affected by the motion of the wedge acting against it. So F minus 4 over 5 A. So you can rule out the 3 over 5 and the A because they're not going in the same, they're not in the same line of motion. So you can just completely rule them out. Don't even need to look at them. Okay. Now that's the first one. We're going to multiply both sides by 5, make this easier on ourselves. 3mg equals 5mf, and then minus 4a. Okay guys, now we're going to look at the next equation. So this one here, done and dusted, box it off. Yeah. It is 4ma, I keep doing that, don't I? 4ma, because you multiply by the m, by the a, and then you multiply by 5. Okay, thank you. So that's this whole system here, completely done. And that's your second equation, so you can just send it over to the side, box it off. Now you're on to your next equation. F equals ma, except it's gone diagonally down. Okay, so we're going to just have a quick look up at your diagram. So what's forcing it directly downwards in that direction here? 4 over 5 mg, perfect. Then what's working against it? The r value. And then after that, so it's just m, yeah, and 3 over m multiplied by 3 over 5a, the acceleration in that direction. Okay, so m times 3 over 5a. Multiply by 5, 4mg minus 5r. Remember to multiply in by m as well, 3ma. Alright? Yeah. Or just by, it's the reaction force. So if you hold an object, it's the force that the object experiences when you're holding it up. So it's like when we're standing on ground, what you feel through your legs is a reaction force going up. It's like it's actually sorry. It's like when somebody was to, let's say, stand on your back. You're supporting them, so all their weight, because you're supporting them directly, you feel the reaction force because you're supporting them. They just yeah. So what we have here is we have our three formulas. Okay, can't remember this one here. I haven't treated that one yet. So I'm going to multiply both sides by 5. We're going to get 3r equals 50 ma. Oh, sorry, 20 ma. Does everybody see that? Multiply this one here by 5 both sides. 3r equals 20 ma. That's equation A. And where's the r? So in this question here, guys, we only have to figure out the acceleration of the wedge. So we don't need to figure out f. So all we need to do is go plug this 3r or the r value directly up here. Okay, so we'll know that r equals 20 ma over 3. So put it into that equation there. For mg minus 5 times 20 MA all over 3 equals 3 MA. We're going to multiply both sides by 3. 12 mg minus 100 MA equals 9 MA. 12 mg equals 109 MA. A therefore is 12 over 109 G. The ends will cancel and then just divide the 109. Okay, and we're correct.